am Dilip Udani, Assistant Professor at MCA, Institute of Engineering and Technology. Today in multiple integrals, I will teach you new topic, that is double integrals as volume. So let's start. So first of all, we will see what is double integral as volumes. When a surface z equals to function of xy is continuous on the region R and function of xy is greater than or equals to 0 for all xy in region R, then double integration of function of xy dA over the region R is the volume of solid region between the surface z equals to function of xy and the region R in the xy plane. The formula to find the volume in Cartesian coordinates using double integral is given by V equals to double integration of z dx dy over the given region R. The formula to find volume in polar coordinates using double integrals is given by V equals to double integration of z replacing dx dy by r dr d theta over the given region R. Now we will see examples related to this topic. This is example number 1. Find the volume bounded by the cylinder x square plus y square equals to 4 and the planes y plus z equals to 4 and z equals to 0. So here is the solution. Volume V, that is equals to double integration of z dA over the given region R, and this is equals to double integration and z, that is nothing but 4 minus y from this equation, and this dA will be as it is. Now this is the diagram. You can see from the diagram that this is a z equals to 0 plane, and this is y plus z equals to 4 plane, and in between these two planes we have a cylinder x square plus y square equals to 4, and we have to find out the volume of this cylinder, which is bounded by z equals to 0 plane and y plus z equals to 4. Using polar coordinates, find out the projection of this solid in the xy plane. You will find the equation will be x square plus y square equals to 4, and this is the equation of a circle having center 0 0 and radius equals to 2. So if we are going to find out this integration in polar coordinates, then we require the limits of r as well as limit of theta. Now you can see from this diagram that here at this point you will find the value of r equals to 0, and if you will consider the strip like this, you will be having the value of r at the point which is on the circle will be 2. So definitely the value of r will vary from 0 to 2, and you can see from the diagram that the theta will vary from minus pi by 2 to plus pi by 2. But we have to consider this whole circle, so in the integration we will multiply the result by 2. Therefore the volume V, that is equals to multiplying this whole result by 2, so it will cover this whole circle. So this is equals to 2. Now this is the limit of theta, that is integration from minus pi by 2 to plus pi by 2. And integration from 0 to 2, and this is the limit of r. Then after, this is 4 minus y, so 4 will be as it is, and y, that is nothing but r sin theta, and dA equals to dx dy, but here we are using polar coordinates, so dx dy, that is equals to r dr d theta. Now this is equals to 2, integration from minus pi by 2 to plus pi by 2, integration from 0 to 2. Now multiplying this result by r, so we have 4r minus r into r, result is r square, and sin theta will be as it is dr d theta. Now first of all we will integrate this function with respect to r, keeping theta constant, it means we will keep sin theta constant. So integration of r, it is r square by 2, and integration of r square, it is r cube by 3, and this sin theta and 4 will be as it is. So this is equals to 2, integration from minus pi by 2 to plus pi by 2, 4r square by 2 minus r cube by 3 sin theta, and limit is from 0 to 2 d theta. Now this is equals to, the volume V equals to, this 2 will be as it is, integration from minus pi by 2 to plus pi by 2. Now replacing r by 2, so it is 2 square is 4, 4 into 4 16, and 16 divided by 2, that is 8. Then after this minus sign, 2 raised to 3 is 8, so 8 by 3 into sin theta, and then after for lower limit 0, these two terms will become 0, and this d theta will be as it is. Now you can see that we will apply this integration on these two functions. One is on 8 and other is on 8 by 3 sin theta. But as all of you know that sin theta is an odd function, and integration from minus a to a f of x dx is 0 when f of x is an odd function. So integration from minus pi by 2 to plus pi by 2, 8 by 3 sin theta d theta will become 0 from this result. And we have integration from minus pi by 2 to plus pi by 2, 8 d theta. Now again we will apply the same concept on this function, but 8, that is a constant value and it is an even function. So in case of an even function, integration from minus a to a f of x dx, it will become 2 times integration from 0 to a f of x dx. So 2 into 2 it will become 4, and integration from 0 to pi by 2, 8 d theta. Now 8 into 4, that is 32, and integration of 1 with respect to theta, answer is theta, and for upper limit pi by 2 it is pi by 2, and for lower limit 0 it is 0, so pi by 2 minus 0, that is pi by 2, and pi by 2 into 32, that is equals to 16 pi. Therefore the volume V, that is equals to 16 pi. Now we will see second example. Find the volume of the solid that lies under the plane 3x plus 2y plus z equals to 12 and above the rectangle R, that is equals to x comma y, where x is between 0 to 1 and y is between minus 2 to 3. So here is the solution. Volume V, that is equals to double integration of z dA over the given region R. So this is equals to double integration. Z is nothing but 12 minus 3x minus 2y, and dA is dy dx. Now using Cartesian coordinates which are given to us, 0 less than or equals to x less than or equals to 1, and minus 2 less than or equals to y less than or equals to 3. So the limit of x is from 0 to 1 and limit of y is from minus 2 to 3. Therefore volume V, that is equals to integration from 0 to 1, integration from minus 2 to 3, and this function will be as it is, that is 12 minus 3x minus 2y dy dx. Now first of all we will integrate this function with respect to y, keeping x constant. So this is equals to integration from 0 to 1, 12 is a constant value, and integration of 1 with respect to y, that is y. So the result is 12y. Then after minus 3x is constant, and integration of 1 with respect to y, that is y. So the result is minus 3xy. Then after minus 2 will be as it is, integration of y, that will be y square by 2. So 2 will cancel out, and the limit is from minus 2 to 3, and this dx will be as it is. Now this is equal to integration from 0 to 1. Now we will find out this function for upper limit 3, then after minus sign. Then after we will find out this function for lower limit minus 2. So replacing y by 3, so 12 into 3, 36. Then after replacing y by 3, so 3x into 3, that is 9x, so it is minus 9x. And 3 square is 9, so it is minus 9. Then after minus sign, replacing y by minus 2, so it is 12 into minus 2, that is minus 24. Replacing y by minus 2, so minus minus plus, 2 3 is 6x. then after minus 2 square is 4, so it is minus 4. Now we will simplify this result, and this is equals to integration from 0 to 1, minus 9x minus 6x, so the result is minus 15x, 36 minus 9, that is 27, minus 24 and minus 4, that is minus 28, minus minus plus, so it will become plus 28, plus 27 plus 28, the result is 55. Now we will integrate this function with respect to x. So this is equals to minus 15 will be as it is, and integration of x is x square by 2, plus 55 will be as it is, and integration of 1 with respect to x, the result is x, and the limit is from 0 to 1. And this is equals to, now replacing x by 1, so it is 1 square, and 1 square is 1, multiplying 1 by minus 15 by 2, so the result is minus 15 by 2, replacing x by 1, so it is plus 55. Then after for lower limit 0, these two terms will become 0. Now we will simplify this result, 55 into 2, 110, and 110 minus 15, that is 95. So the answer is 95 by 2. So this is the answer of given problem. So in today's lecture we have discussed how to find out volume using double integrals, and we have gone through 2 examples related to this topic. Thank you for watching this video. I will see you in the next lecture.